Alright guys, welcome to the second semester. We're going to start off with something pretty easy. This is basically just the Pythagorean theorem, which only applies to right triangles. And what we do is if we have a right triangle and we have two sides of a triangle and we want to find the third side, our formula is c squared equals a squared plus b squared, where c is the hypotenuse. You know the hypotenuse because it's the longest side and it's opposite the right angle. So if we look at this carefully, we know the hypotenuse is x, so that's x squared. We know one of the sides is 8 squared and the other side is 6 squared. It doesn't matter the order in which you do these, so if you had written 6 squared plus 8 squared, that would have worked just as well. X squared is equal to 64 plus 36, and so x squared is equal to 100. We square root both sides, and we get x is equal to 10. Now I know I've talked with one or two of the classes about this. This is what's known as a 3, 4, 5 triangle. If you wanted to, you could have just said this was a 3, 4, 5 triangle and that x was equal to 10, and that would have worked just as well. For those of you that don't remember, or if I haven't talked about it, the numbers 3, 4, and 5 will always form a right triangle because 3 squared, which is 9, plus 4 squared, which is 16, so 9 plus 16 gives me 5 squared, which is 25. And any multiple of these will work as well. So for example, 6, 8, and 10 is 3 times 2, 4 times 2, so it matches that this should be 5 times 2. And you'll see this a lot, so I would just memorize this one. And the other one you want to memorize is 5, 12, and 13. Oops, let me write that outside there because that's not part of it. But 5, 12, 13 triangle is another one. And there's a third one, but it's not used that much, but 8, 15, 17. If you recognize the triangle, you can go ahead and say it's a 3, 4, 5 triangle, therefore we're good. So again, going back to this, using the Pythagorean theorem, this is my c squared, a squared, and b squared. So we plug it in, we do the work, and we get our answer. Alright, here's another one. If you notice, I guess it's a 3, 4, 5 triangle again. So we want to know if the unknown side is a leg or a hypotenuse. The hypotenuse ends up being 5 right here, because again, it's opposite the right angle. It's the longest side. So therefore, x is a leg, and we want to find the unknown side. I could just say this is a 3, 4, 5 triangle, and x is equal to 4. If we wanted to do this time it would be 5 squared is equal to x squared plus 3 squared. And this is if you didn't recognize it was a 3, 4, 5 triangle. So we get 25 equals x squared plus 9. Subtracting 9 from both sides, those cancel. We get x squared is equal to 16, and square rooting both sides, we get x equals 4. Okay? So it's a leg, and x is equal to 4. Now, this is not a 3, 4, 5 triangle, so we have to do the work for it. If you look, this is opposite the right angle. It's the longest side, so this is a hypotenuse in this case. So in this case, this is my c, these are my a and my b, so we would say x squared is equal to 4 squared plus 6 squared, and we get x squared is equal to 16 plus 36, so x squared here is equal to 52. And if we look carefully, it does say simplest radical form, so we have to break it up into its simplest radical form rather than giving a decimal answer. In this case, we know that if you know a deck of cards is 4 suits, and each one has 13 cards in it. So we have our hearts, our diamonds, our clubs, and our spades, and each of them has 13 from an ace all the way up to a king. Therefore, this 4 can come out as a 2, and my answer is 2 rad 13. And it's a hypotenuse. 2 rad 13 is my answer. And that's all we have. Thanks.